I'm going to show you more chain rule practice. So this is the second day of chain rule. All right, and I'm just going to go straight to the pattern. So chain rule is used when you have what are called composite functions. So these are functions within other functions, multiple functions. And if you're going to take the derivative of a composite function, you start by taking the derivative of the outside function, and then all of the inside functions stay the same. Then you go to the next outside function, which in this case would be g, and I'm going to multiply times the derivative of the g function, keep all the inside functions the same, and then the innermost function would be last. I'm going to take the derivative of that, and that would go on the end. So you always work from the outside in. All right, so this first one, for an example, whenever you have a trig function with a power in this position, here's what I recommend that you do. I recommend that you rewrite it the following way. Make sure you put brackets around the entire trig function and raise the entire function to the third power in this case. It just helps with recognizing the different composite functions. So in this case, I actually have 3 functions. So here's my innermost function. It's the 2x. The next function is the sine. And then the outermost function is the grouping symbols raised to the third power. So in order to take the derivative, you start by taking the derivative of the most outer function, which is the parentheses or brackets raised to the third. So I'm going to write y prime. So the outermost function is 3, is going to go to the front. I leave the brackets, and then the 3 becomes a 2. So that's taking the derivative of the outside function. Now, everything on the inside stays the same. So I am done with this one. Check. The next one is the sine function. So I'm going to multiply times the derivative of the sine function, which is cosine, and then leave the inside function the same. So this one's now done. And then the last piece is taking the derivative of the innermost function, 2x. So the derivative of 2x is 2, and you can leave it just like that. You do not have to simplify that. All right, for example 2, again, we have another trig function with a square here. So I'm going to rewrite it. Secant x cubed minus 4, and this is all squared. So here's my innermost function. The second function is the secant, and then the quantity all squared. All right, so I'm going to start with the outermost function first. So that would be bringing this power to the front. So the 2 goes here, and then this is going to be raised to the first power. You don't have to put the 1 there. I just want to emphasize I took the derivative. And the inside function stays the same. All right, so that one's done. Check it off. Now I'm going to multiply times the derivative of the next inner function, which would be the secant, and the derivative of secant is secant tangent. So I write secant, parenthesis, tangent, parenthesis. Now I leave the inside function the same. So I keep the x cubed minus 4x cubed minus 4. So that one's done. And then I'm going to multiply times the derivative of the innermost function. So the derivative of x cubed minus 4 is 3x squared. All right, third example. All right, square roots and radicals, not everybody's favorite, because you end up having to deal with fractional exponents. So you could do quotient rule here, but now we can finally do chain rule and avoid doing a quotient rule in this case, and that would be by rewriting this denominator and moving it to the numerator. But when you do that, the exponent will then have the opposite sign. So I'm going to rewrite this equation here by putting cosine of 2x plus 1, and that's now going to be raised to the negative 1/2. Half because it's a radical, and negative because I moved the denominator to the numerator. All right, now I'm going to emphasize my different composite functions. I have the 2x plus 1. I have the cosine, and then I have the parentheses raised to the negative 1/2. So let's see, y prime. So the outermost function here, I'm going to take this exponent, move it to the front, and then I'm going to be subtracting 1. So I just put minus 2 over 2. So that's negative 3/2. And everything on the inside stays the same. And then I'm going to multiply times the derivative of cosine. Well, the derivative of cosine is negative sine. And then everything on the inside stays the same. Oh, so I did this one, and now I just did that one. And then I'm going to multiply times the derivative of the innermost function. So the derivative of 2x plus 1 is just 2. And that one's done. And there you go.